Hello, welcome back to lesson 2 in our unit A, and today's lesson is called the classification of matter. So in the last video, we talked about the definition of chemistry, the definition of matter, the different phases of matter, and some of the different areas of chemistry. So now we're going to take up what we know about matter and classify it further. So we'll talk about classification of matter, types of mixtures, as well as the differences between elements, mixtures, and compounds. So here is this flowchart of matter, and right now it's blank, but as we go through the video today, we're going to work towards filling in all of the boxes. So first we're going to talk about how if it can be physically separated, but even before we get that, a quick reminder that matter is anything that has volume and mass. So it has mass and it takes up space. So then once we know that it has both of those things, the next question we ask ourselves, well, can it be separated physically? And we're going to spend a whole nother video going over how to separate stuff. And if the answer is yes, that is a mixture. And then we can talk about what kind of mixture it is. If it's uniform, we call it homogeneous. If it's not uniform, we call it heterogeneous. And then if we backtrack and go, if we can't separate it, we call that a pure substance. We can't separate it physically. If it can be chemically decomposed. If the answer is yes, it is a compound. If the answer is no, it is an element. That's a whole bunch of info thrown right at you. That's the overall, goal of this video is going over how to get through this chart and what all these new terms mean. So first is, let's talk about a mixture. So that was one of the first things that was introduced here. Now a mixture is made up of two or more things in the same place at the same time, not chemically combined. So the not chemically combined part is super, super important. So if we look at this picture of trail mix, we have some granola, we have some M&Ms, some raisins, some nuts. All of those things are in the same place at the same time, but the M&M is not chemically combined to the almond. They're all still their separate things. In mixtures, one of the characteristics of it is that the composition can vary. So this bag of trail mix may be different from another bag of trail mix that you buy from a different brand. Mixtures are physically separated, or physically combined, and can be physically separated. So if we wanted to, we could pick out all of the M&Ms, pick out all of the almonds, and separate it into its different pieces. And again, later on, we'll talk about the different ways you can separate a mixture. So again, you can separate them physically by not using chemical reactions and properties, just pretty standard techniques, which we will get into later. So some examples of these properties, or these methods in which to separate stuff physically: evaporation, boiling, literally just picking it out, like I mentioned before, just picking out all the different things, using filter paper and more. But again, this is the topic of next video. So don't worry about if you're not sure what all that stuff means yet. Just know that mixtures can be physically separated. Now, if we're talking about a mixture, there are two different types of mixture. And in order to tell what type of mixture it is, you have to look at the composition, or what makes up that mixture. And so if we say the composition is uniform, meaning it's the same throughout, so we can just write same/uniform throughout, we call it homogeneous. Now homo, the prefix, literally means same. So in this picture of homogeneous mixtures, if you take a sample from that corner, or if you take a sample from this corner, you're getting the same pieces. So here you have 2 pink and 2 green. If you take from down there, you have 2 pink and 2 green. The uniform is constant. It is the same. It is uniform throughout. That is what homogeneous mixture means. Now, on the opposite hand, if the composition is not uniform throughout, or it's not the same, we call it heterogeneous. And so here, if we're going to take a sample from the corner of this box and the corner of that box, you're getting different things. So if you do not have uniform or the same composition throughout the entire sample, we call that heterogeneous mixtures. And we'll go through examples as to what these look like in everyday life. So moving forward on homogeneous mixtures, again, the composition is uniform. So this is a super important part that you're going to see a bunch of times. And what that means is that there is no visible differences. So it looks like one thing. You can't see different pieces. It looks the same. And if you were to take samples from two pieces of that, or from two different areas of whatever thing you're looking at, those samples should be exactly the same. So again, if you take a corner from here, or if you take a corner from here, you get the same thing. So some examples of things that are homogeneous mixtures are things that are dissolved in water. So if you have lemonade powder, you put the powder in the water, and then all the powder dissolves, evenly spread throughout, and you got yourself some lemonade. That is a homogeneous mixture, and key point here is completely dissolved. If you were to have stuff stuck on the bottom, that is not homogeneous because it's not uniform throughout. Another great example is air. There's a whole bunch of different gases that are in the air that you're breathing in right now. You can't see the difference, and unless something you're standing behind a truck releasing these fumes, it's the same everywhere. Okay, taking a closer look at heterogeneous mixtures, the composition here is not uniform, so it's going to be different in different areas. And here you can see these visible differences more. And if you were to take a sample from two different sections of whatever you're looking at, those different samples will be different. So again, if we take a top corner sample here and a bottom corner sample there, you have different things. You can see these different parts to it. So some examples of heterogeneous mixtures are a solid sitting in a beaker of water. So here is your beaker of water. Here is a solid. And air, we said this was homogeneous, and most of the part it is. But if someone sprays perfume, so here's your little perfume bottle, and someone sprays this out, right there is no longer homogeneous because it's not evenly spread out. Eventually, it will spread out to become homogeneous, but it depends on the situation. So here we have some fruit salad. Is it homogeneous or heterogeneous? So is each sample going to be the same or is it different? Now here would be heterogeneous. So if you took a spoonful of fruit salad from there, a spoon of fruit salad from here, you're going to get different things. Homogeneous or heterogeneous, our lovely cup of lemonade. This is indeed homogeneous. If you were to take a sip from up there, if you were to take a sip from down there, granted it was stirred completely, it's the same, meaning it is homogeneous. Again, here you know you have lemonade powder and you know you have or sugar and water. You know there's different things in it, but you can't see those different parts. So that's how we know it's homogeneous. But if we go back to the fruit salad, you can obviously see the grapes, the pineapple, the strawberry, the kiwi. You can see those different parts. Here we have some oil and water, and this is another example of heterogeneous. We have oil, we have water, and they're not mixed together evenly. So if you take a sample from up top, take a sample from down below, you get different samples. You can physically see the different pieces. That is heterogeneous. Here we have some pancake batter, and it looks like it's stirred pretty well without chunks. So if we're going with batter without chunks, that is homogeneous. So again, you know there's different things in it. You can't see those different parts. Everything looks the same. That is homogeneous. Now, here again, we have our flowchart. So hopefully now this makes a little bit more sense. So again, if we know something takes a space and has mass, we know that it is matter. And then we're able to look at, can it be physically separated? And we just covered, this. Again, we'll get into how to separate these mixtures later on. But we still got to talk about pure substances. And so a pure substance is anything that cannot be separated by physical means. And so here a composition is definite and constant and has distinct chemical properties. So if we think back to our fruit salad example, I might make fruit salad differently from the way you might make fruit salad, and that might be different from the way you buy fruit salad, but it's still fruit salad, so the composition can vary. But here we have some salt, and salt is NaCl. You always have one Na and one Cl, and so that's not changing. We can't physically, with our hands or very, very minor separation techniques, pull apart that Na and that Cl to make those separate pieces. So we say that it is a pure substance or a chemical substance. Now, the difference between compounds and elements. Compounds are made up of two or more different elements, and we'll get into this more and more as we go on. But if you have two or more different elements, so anything on the periodic table, two or more different ones, they are chemically combined together, that is a compound. So compounds are chemically combined. So there is that chemical, combined, compound, all those C's. Now, compounds can be broken down and formed through chemical reactions. You can't just put the two molecules together in your hand. So some examples, H2O, CO2, and glucose. You have two or more different elements stuck together chemically to form that compound. Now, elements, on the other hand, are the simplest form or the simplest substance. Now, elements cannot be broken down by chemical reactions. And some examples are O2, which is oxygen, Ne, which is neon, and C, which is carbon. Now, we'll get into this later on. Oxygen is O2. So you have two of the same elements stuck together. That's still an element. Again, things we'll get into later on. Compound is two or more different elements. Element is one element. So again, here is our chart. We covered mixtures first. And again, you have we call these particle diagrams, and we'll get into how to draw those later on. We have those, and we just talked about pure substances, elements, and compounds. So here is your flow chart again. And again, as we go through this unit, we'll talk about these in more and more detail. So on that note, that is it for this video. In the next time, we'll cover different types of separation techniques like filtration, distillation, chromatography, evaporation, and more. So on that note, have a wonderful day. Bye.